about to start. Oh crap. Okay, today we're working on 10-4's lesson. It's inscribed angles and polygons. We're going to be learning about inscribed angles. It's angles whose vertex is on the circle and whose sides are chords. So right here, this is one of our inscribed angles. We've already talked about the central angle and the intercepted arc. Okay, here is more about the inscribed angles. It just describes it again and shows you just what I said. Inscribed angles, vertex is going to be on the circle. That is the inscribed angle. The arc that goes with that would be the arc that's going to go from A to C. That is going to be the intercepted arc over there. Okay, here's a theorem. The measure of an inscribed angle. The measure of the inscribed angle is going to be half of what the arc is over here. And our inscribed angles can look these three different ways. We have case one, whose goes through the center. My vertex is still over here on the circle, but one of my chords goes through the center using the diameter. We have another one over here. Vertex is on the circle. So it can look like any of these three types. Okay, let's practice, because we said that the angle is going to be half of the arc. So if we go over here and look, they want us to find the measure of angle T. Well, angle T is going to be this angle right there. Let me erase. Hang on, I'm erasing. Because I don't know why that's there. There we go. Okay, so that is angle T. So for angle T, we're going to come over here and look at it. It has a vertex that is on the circle. So I come over here and look at what is the arc that goes over here with that angle. The degrees for that arc is 48. So if the degrees for my arc is 48, we know the angle is half of the arc. If the angle is half of the arc, we would do 48 divided by 2, and that would give us 24. So we know that angle measurement would be 24 degrees. Next thing that they ask us for is the measure of arc QR. They want to know, what is this arc right here from Q to R? Okay, so let's go look and see what they gave us. I'm going to erase the other one that we did. Okay, we know right here that TR is going through the center, so TR would be our diameter. If that is our diameter, we know that from here to here, this whole thing is a half of a circle, a semicircle, and the degrees for that is 180 degrees. Then we go look at the inscribed angle that they gave us. They tell us right here that this angle is 50 degrees. That angle is right there. If the angle is 50 degrees, we know the arc we have to multiply the angle times 2 to get to the arc. So our arc over here, that would be QT, would be 50 times 2 is 100. So our arc for that one is 100 degrees, but that's not the one we're wanting. We're wanting QR. So QR is going to be what's left over from that half of the circle. So if I go 180, since it was half circle, minus the 100 degrees, what's left over is going to be 80 degrees. So our QR would be 80 degrees. Okay, there's one for you to try. Okay, finding the measure of an intercepted arc. They ask us to find the measure of arc RS. If we come over here and look, RS is this arc from there to there. So let's go look and see what they gave us. They gave us that angle SUR from S to U to R, that angle right there is 31 degrees. It is the intercepted arc. It actually, intercepted angle, sorry. It actually goes with that arc. So if that angle is 31 degrees, we always multiply the angle times 2 to get to the arc. So 31 times 2 would make that arc 62 degrees. Then they ask us to find the measure of angle STR. I'm still going to use this picture and the same color, same drawings on there, but I'm going to go in a different color. Because if I go look at STR, we need to find that angle. Well, when we look at it, our ends go over here to the S and the R just like the other angle did. So it actually is using the same part of the arc on the circle. So if we got the arc to be 62 degrees, we know if we have the arc, we divide it by 2 to get the angle. So it would be 62 divided by 2, it would be 31. So it's actually the same as the other one down there. So we know that these two angles, when it asks us that question right there, those two angles would be congruent. We know those two angles are congruent. They are both 31 degrees. Okay, here is a theorem. It's inscribed angles of a circle theorem. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Okay, they show us right here. Those two angles are congruent, and they are congruent because when we go and follow our angle to see what arc it goes with, that goes with arc AB. And if we go and follow the other angle, that angle would also go with arc AB. Let's try. Name two pairs of congruent angles. If I go BCD, that is an angle we can use right there. And the arc it goes with would be arc BD. Then if we look over here at angle BAD, it goes and meets at the same place as the other one. So actually, it would be angle BAD would be congruent to angle BCD. Okay, let's practice. Okay, we are given that angle E is 75 degrees, so that is our inscribed angle, and I'm just going to follow it out. I always just follow it out so where my chords kind of extend past the edges of the circle, so I can go over here and see where it touches on the circle and what arc it would go with. So that would actually go with arc GH right there. If arc GH is right there, let's go. They want us to find the measure of angle F. And I'm going to just erase all that so it doesn't look like it's too much. Okay, angle F. Angle F goes from here to here. On my circle, the points that it crosses for the arc would be the G and the H. So basically it's crossing the same ones that we would have to use on angle E. So if angle E was 75 degrees, that would also make our angle F 75 degrees. So they are actually congruent. They are crossing, and our angles are crossing and hitting at the same points in the circle, so it's using that same arc over there. Okay, here is one for you to try. Well, it's you try, and I'm going to go do this one with you because the more practice I'm going to let you do on your own. Okay, let's try this one. So if angle C is 68 degrees, the angle intercepts and comes over here on the circle would go from A to D. That's the arc it would use. They want us to find the measure of angle B. So if I come over here and go to angle B and outline it and follow it, it meets and goes at the same places that angle C did. So if angle C is 68 degrees, then angle B would also be 68 degrees. Now there's the one that I want you to practice. Okay, now we're going to talk about using inscribed polygons. This is when they put a polygon inside the circle. It is circumscribed inside the circle. Okay. Inscribed right triangle theorem. So if a right triangle is inscribed in a circle, then the hypotenuse is the diameter of a circle. So we have a right triangle right here. Here's my hypotenuse, which is the diameter of the circle. They're going to say that the angle opposite the diameter, which is right there, would be 90 degrees. That's true. Let's think about this. If we go back and think about what we've already worked with in this section, if we went with this angle right there, that angle right there goes from A to C for our arc. And that, if we notice, is from A to C is half the circle. It's a semicircle, and half of our circle is 180 degrees. From one of the theorems we used earlier, the arc, whatever the arc is, the angle will be half of it. So if our arc is 180, then this angle must be 90. And this is just a theorem that sums that up and shows that to you from the stuff that we learned earlier. Okay, now let's go look at the next theorem. Inscribed quadrilateral theorem. If a quadrilateral, and a quadrilateral is a shape with how many sides? 4 sides. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So what they're saying is, if I added angle D plus angle F, it would equal 180 degrees. Angle D plus angle F equals 180 degrees. Both of the pairs of opposite angles have to be supplementary. So on the other side, we have angle E plus angle G over here. Now I put that they're congruent, and I so didn't mean to. I was just showing you those angles. Angle E plus angle G would also have to equal 180. And if it doesn't make any sense right now, when we go do and practice on it, it will make more sense. So using inscribed polygons, let's practice. Find the value of each variable. Okay, I'm going to go over here. What they gave us is that angle C is 2x, and there is a triangle inside that circle. So if I'm just talking about that angle right there, and I want to solve for x, if I came over here and went that way, that's my angle is going, and my angle touches at A, it also touches at B. And if we look at what A to B is the what? Half the circle, which is the semicircle. That is 180 degrees. If that is 180 degrees, what is the arc angle? The arc is 180, and our theorem earlier said if we would always go, whatever our arc is, we go and divide it by 2, and that gives us the angle, because we're talking about the angle with the vertex on the circle. So if the arc is 180, then that angle must equal half of that. So we have 2x equals 90. And when we go and divide that out, we get x equals 45. Okay, let's go and try the other one. We have a quadrilateral, a shape that has 4 sides inside of our circle. And our theorem said, when we add our opposite angles, this angle and this angle, if we added those together, they would be supplementary. So our sum would be 180. So there's the equation I would use to solve for y. So when I go and solve that, I should give that y equals 60. Okay, let's go and solve for z. Okay, the same thing. Let's go look at z. Z is right here. Its opposite angle is the 80. So same theorem. Opposite angles are supplementary. So if I add z plus 80, being supplementary, they should equal 180. So to solve for z, when we go and subtract the 80 out, we should get that z equals 100. Okay, let's go and practice these together again. Same concept. If I look at this angle, that angle right there, the arc it touches is going from W to Y. Now W to Y is half the circle. Degrees for half a circle is 180 degrees. That's the measure of my arc. So the angle would be half of that. So we know, since the arc is 180, our angle should be 90. So my equation would be 5x equals 90. You would go and divide that out and get x to equal 18. Then the other theorem, we just talked about it, and we know that if we add our opposite angles together, if we added the opposite angles together, they should be supplementary. So adding angle D plus angle B should equal 180 degrees. So 3A plus 111 would equal 180. We go over here and subtract our 111 from both sides, and we would get 69. So 3A would equal 69, so A should equal 23. Okay, let's go find what B is. If we go look over here, if I add angle B plus the opposite angle of, I'm sorry, not angle B, it's angle A plus the opposite angle that is angle C, their total should be supplementary. So B plus 65 would equal 180. When we go and subtract 65 from both sides, we would get B equals 115. Now these are ones for you to practice.